Welcome, everyone. Thank you for tuning into this or watching this on replay. So this is our latest installment of new and interesting things for Informix users. This talk is going to be a combination of some of the new tools, some of the new features, some of the new utilities out there that'll complement the Informix user base quite nicely. This also will serve to help anyone that may be looking at getting into Informix or maybe involved with NoSQL or some other areas and want to see, what us relational DB people are on about, when we start doing crossover. So, quick slide on me. I will put these slides out after the fact, by the way, so don't feel you have to take notes. So jumping right into it, some of the new technology that's come into Informix in the last couple of years. The big thing that came out was Informix came out with release 12.1 a few years ago, and it brought forward, besides a whole lot of performance improvements, it brought in a lot of new features that are very useful for people and are often overlooked. Some of the key features that we have found that are really new, for one, it's the NoSQL support. We'll talk about this quite a bit today, which also involves connection to the Mongo API. It includes the fact that it now has a REST listener. The Node-RED support, which Node-RED is a separate product, but ties in. We're also going to talk a little bit today about Spark and IoT data visualization, which are brand new initiatives by IBM. Spark not being a new product, but it's something where IBM is now working with it. Some of the new features of version 12 in particular that are very useful, that are often overlooked, and I want to mention briefly, but I'm not going to go into detail on any of these. One is the new PSM storage manager. If you'd worked on version 11 or earlier and tried to use the built-in storage manager to write data out to disk, you found it was very cumbersome and not terribly quick. New PSM manager is very easy to set up, very easy to manage, and is lightning fast. I've been thrilled with it and doesn't get enough press. Multi-tenancy, which there's some great material out there on this. This is allowing Informix to have dedicated resources by user, so you could really segment off your database and your instance to be far more flexible, responsive, and also keep, your problem children users into their own little sandbox without having to have separate instances running. They have done the IBM development team has done some amazing things with improving the time series features, making it much more flexible, much more robust. The SPL includes the case statement. This is one little change that a lot of people don't know about, but many people have been asking for years. The introduction of grid queries when using the enterprise replication. There's some great presentations out there on it. If you're using ER, it's certainly worth looking into. Bluemix integration. Mike Walker's talked a lot about Bluemix in his presentations. It is a big initiative IBM has to offer cloud-hosted data management, data storage, development, everything else in cloud offerings. I'm not going to cover it in this talk, but most everything we're doing here does have ties into Bluemix as well, if you want to go that route. And the other one that I'm personally excited about, we've done a number of webcasts on, is the fact that Informix now runs on ARM and they just keep making it better and better. So I'm going to be running some demos today. Speaking of the ARM, this is what we're going to be running with. I have a little QB truck. This is small, dual core ARM system. It's the, about the 2.5, 3 inches long, 2 inches wide. And then on the bottom, a little homemade sensor. This is very simple. It's using a wireless connection. It's using some very basic programming and a small temperature and humidity sensor to give us some basic readings. I just have it running off a battery pack right now, which is what the IBM piece is. So I'm going to jump into NoSQL here. If you're a NoSQL person on this call or on the replay, you know all of this already, but a lot of people from the relational world are not familiar with NoSQL, or they know it as a buzzword. They don't know what it actually entails. The first time we started talking about NoSQL at an Informix meeting, half the people in the room almost simultaneously ask the question of, why would we ever use this? What does this do for us? NoSQL is, while it is a fairly new technology, it is also a fairly old technology. It is all unstructured data. Most of the time these days, it's stored in JSON or BSON, which is the binary formats. Previously, you might have worked with XML or even UML or several of the other markup languages. JSON's just far more compact. Everything, and this is where I say it's also an old technology, is stored in key value pairs. I should not say everything. There are some NoSQL that do other options, but most of them and everything we're looking at today will be in key value pairs. The nice thing when you're dealing with this kind of unstructured data where you just have the value pairs and can put them however you want, is it allows you to put many different types of data, including arrays, even nested arrays in some cases. You can involve some level of binary data. You can involve all kinds of different data types into a single record, making it much easier to do lookups. NoSQL is a generic term. It means many different things to many different organizations. So be aware that just because something says NoSQL doesn't always mean it's the exact same type. Some of the common ones, the most common, and there is certainly bleed over between these four categories, is the key value pairs. These are just simple. It is straight column name or value key name, and then the value, just stored together. There are things called graph stores. These are specifically for doing mappings, doing linkings, having different nodes that connect together, and being able to traverse those nodes as fast as possible. It's really good if you have data that you're connecting locations or people or need things where you need those relationships. There's wide columnar databases, which this is the traditional column-based data, and oftentimes they're stored where are called super elements, which are almost an entire row, almost an entire data structure in a single column rather than in a row. And so it makes it very quick to do aggregate data. This is very similar to how time series is stored. And the final one, which is document databases, are where you'll store full documents or extensive JSON, full actual documents if it's binary, or things like JSON documents, where it will actually store all of the information, what would be a full row or even several tables worth of data joined together into a single data element, or into a series of data elements that may have nested. Again, this is all fairly nebulous because that is actually the nature of NoSQL. Is there's a lot of different ways to store your data. So a few of the big ones out there, I did borrow this from, I reference it down at the bottom, arianava.com. But they do a really good job of breaking out some of the different common ones out there where you have your straight document databases like Mongo, which is the one we'll focus on most today, Couchbase, MarkLogic. You have your graph databases. So if you really want to play with some of that, the Neo4j, Infinite Graph, there's a bunch of other ones out there as well. You have your wide columnar ones, your Amazon, your Redis, or your the straight key value databases. The interesting thing is looking up for a decent chart of this, about half of them had some of the database types in entirely different categories. So this is by far not an exhaustive list or any kind of official one, because most of these databases cross over between several of these different types. So in our case, we're going to mainly be looking at document databases because we're primarily going to be focusing on MongoDB integration. So what does a JSON document look like, though? Before we get into anything else with the NoSQL, what is the base JSON document? Because we're going to be dealing primarily with JSON. And it can be simple or very complex. You see in this case, we have the primary ID. So if you think of the first column here as the row, with each of these key value pairs being a separate column, you have your ID, your donut type, your name, the type of donut name, But then the interesting thing is once you get to the batter's key value pair, you notice that it's an array. So you actually then have multiple bits of information stored within that single document. The nice thing with this is the fact that you can return a full data object, not just a single row, or have multiple rows to query against, or multiple pieces where you have to deal with, am I dealing with an inner join, an outer join, am I pulling from this table, what happens if something is not right in that table and then you get a bad join. In this case, you can store your entire data object for this record for your application in a single row. So all you have to do is reference that row, and you now have your full data object back. There are lots of other uses of JSON. For anyone doing web development, it is one of the most common formats to send data across the wire. It is used in a lot of places just to store the data in a fairly compressed format because, well, this one is broken out. The white space does not matter. The returns do not matter, so you can make it very compressed, especially compared to XML, which spells everything out and has a lot of formatting. This is fairly unstructured and fairly minimalistic, making it very efficient. So that's what JSON looks like. So where does NoSQL, have the advantage? Why do I care about this? I've got my big, powerful relational database. Why do I care about this? The biggest one is fast application development. And this is really one of those, there's always, or in most organizations, I say, there is some tension between your application team and your database data integrity teams. In this case, what this is doing is giving the power to your application developers. You're telling your database administrators basically are handling permissions and making sure they have enough room, but basically turning the schema over to your application folks, which can be great or it can be terrible. It just depends on how good they are. What it does, though, is it lets your application developers put whatever they want to in each record. You don't have to worry about adding new columns, changing columns, data constraints, anything else. If they have a new version they want to roll out that has 5 new fields, great. You don't have to change a thing in your table. Just the new records will have those new key value pairs. If they decide that something that used to be an integer is now going to be a text field, you can make that change or change how it's stored and just change your application logic to work. Again, it's a good and bad, but for a lot of places doing rapid development or otherwise getting away from the traditional method of waiting for the data integrity teams to go through, approve new things, they can just have their application team just do it and move on to the next part of the deployment. It also means you get away from having to worry about joins. You get away from having to worry about a lot of the overhead needed with getting separate pieces of data from all of your database. You store it all in the record and you're good to go. Next thing, the big advantage also is it's easy to scale horizontally. Most of the NoSQL databases, and Mongo in particular, are set up to have lots of smaller to mid-range systems that are all working together in one large system, scaled out horizontally with many systems rather than needing one big one. It's easy to handle multiple versions of a document. So if you have 5 or 6 versions of an application, each one the data is a little bit different. You've got I love using car analogies of this, cars.com or AutoTrader or any of those, where if you built that system 10 years ago, you've got your torque, your miles per gallon, everything else. You build it today, you need to have what is the battery capacity? What is the charge time? How many miles per charge? Suddenly those things need to be filled in. But with NoSQL, you don't need new fields. You don't need to have another lookup table. You just have the application developers know that they need to store that, and it'll go into the existing rows, and you don't have to change a thing. It also means if you have tables with very wide rows, that the NoSQL is only going to store the data that you're telling it to store. So rather than having a bunch of nulls for each row, you just won't have that data stored at all, and you won't actually use up that space. The inserts are very quick. It's basically just tossing it onto the queue, which will then insert it as fast as possible. And because you don't have a lot of you aren't inserting into 10 tables with making sure constraints and everything else, and larger systems usually is faster to do a NoSQL insert. You can handle delayed inserts if you're using some kind of middle layer. So you can toss it to the middle, layer application. It'll insert it when it gets to. And if you're using a separated out, horizontally scaled NoSQL infrastructure, it'll just spread out as it can, and you're not having to sit there and wait. And the other thing is you can do direct inserts without having to go through the database layer. They have enough, most of the NoSQL systems have ways to do straight inserts into the database without having to go through larger SQL and larger constraints and everything else. It speeds everything up by removing layers on top of it. So the downsides are most of the same things that are the upsides. Just like it's faster to update because you have fewer layers, it can be faster to insert, it can be slower to update because rather than having indexes and just updating one row on one table, you have to now go that rather than, because data is stored across 5 or 6 tables, everything's stored in one. You have to read most of that record in, update it, and then put it back in. Each of the databases does it a little bit differently, but it's usually slower to do the updates than the relational. Many of the NoSQL databases do not have proper constraints. Some will have some version of them, but most of the time with the concept of NoSQL, you being able to put in whatever you want into your document, it also means you can put in whatever you want into your document. So even if that data doesn't meet some level of constraint, the document is not going to complain on that. You're not going to have something that'll enforce, one particular key value pair has to be in these values or be an integer or something else. It'll just take it, and then your application will have problems with it later on. And because of that, it's easier to get bad data into your database. You ship a bad version of an application, and you now have all these extra fields in there that weren't supposed to be there, or things are stored improperly. Again, not something that can't happen with relational databases, but you have more tools at your disposal. It's hard to connect linking data. So if you have, there are some join options, but they're nowhere near as robust as with a relational. So you're dealing with separate data. If you aren't able to put it all into one place, it can take a little bit longer, or there may not even be proper join options. Most of the application developers I've talked to that deal with NoSQL will just read back all associated rows separately and do the joins in the application rather than doing it on the database layer, so it's not as quick. It's harder to do default values. It all has to be done on the application layer. And you have to trust your developers. If your developers are not people you can trust to get the data right, to handle everything, you're taking most of the database administrators out of the equation. And while it can take a while to get approvals through your DBAs, they're also there to help you out, to make things more efficient, to help make sure things go in the way they're supposed to, and to manage things just to help everybody out. So one of the terms of NoSQL that comes into play, just going over some terminology, is sharding. This is one of the biggest things with horizontal scaling. And the big part with that is you take your data, you split it onto separate nodes. So if you have 10 or 15 different servers that are all running as one cluster, you take the data, you spread it out across the nodes, and then when you do a sharded query, it'll read back from all of the nodes in parallel, so you're accessing all of them for redundancy and speed at the same time, and it makes it very, very efficient. So just a little example of that, get it from actually a Stack Exchange where somebody had put together a really good example of how this all worked, is your clients go and request from your Mongo primary server, the connection manager, a query. The data is sharded across 3 physical systems, and it's split, so there's a primary and then a secondary part, which is rotated between the 3 systems. So for any query you want, it's going to be reading from 3. And at any time that there might be a failure or a server may go offline, it always has a full redundancy available on the remaining systems. So you'd have to lose 2 of your systems of the 3 before you'd have any data offline or data loss. So it is a fairly robust system to do it. And again, it's meant to be, a lot of the NoSQL systems grew up in the concept of having larger numbers of off-the-shelf commodity hardware, where having small, many, many small systems was more efficient than having several large systems. So we're going to talk about Mongo now. This is the one we're primarily focused on. I'm sure most of you know this by now, but Informix now supports MongoDB API. It is a document storage system. It is meant to handle very complex data in each row. It is open source, freely available. It does have some limited indexes. They aren't nearly as robust as relational, but there are some in there. It is wonderful for horizontal replication. It scales out very well. That is a big focus of the engine. It handles load balancing. There is extensive querying syntax options. The Mongo syntax is very, very complex, both good and bad, but it'll let you do pretty much anything you want to do, including scripting inside of your queries, which is very impressive. Some downsides, they don't have traditional constraints as you would in a relational. They don't have transactions. The version 3 of Mongo did introduce a limited transaction set, again, not as robust as a relational database. They're limited as to the types and accessibility of indexes. It doesn't scale very well vertically. I saw a presentation title in IBM Insight where they had to have a special talk just to discuss growing MongoDB over 100 gigs of data. In the relational world, we're talking terabytes fairly frequently, so having those on a single system or a small set of systems is not as efficient in Mongo unless there's a lot of tuning involved. Mongo people that may be listening, if you feel free to argue this with me, I would love to hear your input. I have heard a lot of talk both on small companies and corporations with issues of stability and reliability, where there are many, many reports of the systems becoming unstable and issues with data corruption or inconsistent data going in. A lot of these are based around version 2. Again, I would love to hear more from MongoDB administrators to get your thoughts on this. So Informix, where does this come in? In version 12.1 XC2, the Mongo API support was introduced. This was a big initiative by the Informix development team. They partnered with the Mongo developers to bring over Mongo support into Informix. The biggest thing is that it supports the Mongo command set. So all the query commands, all the complexity there is available to Informix. They added the JSON and BSON data types. So even if you're not running anything with Mongo, you can store data natively as JSON or BSON in Informix. They added the new Mongo wire listener. This is how it supports Mongo applications. And they introduced data sharding, so you can actually do the same kind of sharding as you would with Mongo inside of Informix. This is not an extra feature. If you have Informix 12.1 XC2 or later, this is all available. I would really look at XC4 or later because they've done a lot to improve it and add extra support. So what does the data actually look like? I'm going to jump back to JSON here, but this is, again, NoSQL data. If I go in and do a query, in this case, it's just a very simple sensor data query. I go in, select it just like I would a normal query, and I get back a lot of gibberish. It's partial record. The reason is because by default it stores it in a binary format, so you're not going to get anything back. However, you can cast that field to the JSON data type, and suddenly you're getting back text. So you see here we have a complex JSON document. It's got a couple of subarrays. The big thing to note here is the last field, which is the object ID, which matches the ID on the record. This is a unique identifier. Mongo does the same thing. For each row, we'll automatically have it equivalent of the serial key, but it's doing hexadecimal. So you're dealing with a longer key, but it means that you can have a massively large key store table, and you're not going to have to worry about switching to big serial or anything, or serial 8 or anything else. So to actually get up and running with this, so you've gotten to the point where you go, I'm an Informix developer, or I'm an Informix DBA, and my company is telling me the application developers want to work with Mongo. I'll give you a real life example that we have clients right now that is exactly what they're telling us. On the other hand, you may be a Mongo person coming and going, okay, we need some relational tables. We need to get some of these features, or we're, our company, we've grown, we got huge capital, we're buying this other company, they're bringing in everything relational. We need to get all of this under one roof. So we're going to try moving to Informix. So how do you get started? First thing you want to do is set up the Mongo listener. It actually comes, there's a file in the Informix dir/etc called JSON listeners properties. If you go in there, there's an example file that has all the flags. All you have to do is configure it. There's only 3 or 4 things you need to configure. I'll show you in just a moment. And then you start to commit the listener. You can either do this by the command line. It's a small Java application, or you can do it through SQL and do it through the sysadmin database. And then you're ready to go to start storing data. So the properties file. So again, it comes with the example one, just rename it or call it whatever you want. It is fine to have multiple versions on the system. The fields you actually care about are the listener type of Mongo. The other option is REST, and we'll talk about that in a few. The listener host name. By default, this is localhost. If you wanted to listen on another IP address, just like with SQL hosts, you give it the host name that would be in your etc host files for that particular NIC, or if you want to listen to everything on the system, just use a star. You give it your port. This will be the port the Mongo applications connect to. Security SQL pass-through. This actually allows you to embed SQL in the Mongo commands. There's some security concerns there. Some people like it, some people don't. It depends on your environment. And then you give it your URL. This is your JDBC line to connect in. Again, if you've ever worked with the JDBC driver before, this will look familiar. And just for reference, that's my SQL host that ties into it. So you see how I do Moogle : 10098. That is the port. I have a standard TCP on-sock TCP listener in my SQL host. So what will happen is the Mongo applications will connect into 26351. The Mongo listener will translate those and then pass it through to Informix on the 10098 port. The listener, by the way, does not have to reside on the same system as the Informix database or the application. It can be a third system, and it'll pass it through because it's all TCP connections. So starting it, there are 2 options. The first one is to do set up your Java command, set a class path, and then go in and call the JSON listener jar file. There's a couple of different ways you can configure this. There's lots of the documentation. I link at the end. And it starts it, kicks it off, no problem. The other option is you can execute the function task, start JSON listener, and then you pass on the listener properties file. You can give it some extra arguments for things like if you want a different log file or log level. There's a number of different options you can pass as a third parameter. And that's it. So to actually connect to it, you install your Mongo client package if you want to do testing, or you install whatever, nice misspelled package, whatever application that is based around Mongo, you just install it, ready to go. You tell Mongo, and if you want to do it in the command line, Mongo, you give it the server, port, and then / to the database name. So what you'll get is you connect it, it'll connect and immediately connect into the Mongo shell. You'll get errors if you try and the listener's not working or something's not configured right. So using Mongo, and I'm going to show an example of this in a moment, so I'm going to skim over this, but just some basics, the common one will run in db.tablename.find. That'll do the equivalent of select star from table. An example here using a little bit of the Mongo syntax, db sensor _JSON, that's the table name, find, and then I pass the query parameters, in this case where message ID is then the long string, and I get back just that one row rather than everything. If you have permissions set on the listener, you can go, it'll go ahead and automatically create the table as needed. So if you tell us to do an insert or your application's doing an insert, it'll automatically create the table if it's not there already, which is great because it means you don't need to wait for a new table to be created. You're not locked into a single table. Downside being is if you typo something, you've now created another table in your database. So again, plus and minus, it gives the application folks more control. Downside is it gives the application folks more control. So just some examples also, again, for reference is just, very simple find command. And the matchup between the standard Mongo commands and what that turns into Informix is you have Mongo command is .insert, works the same way. You just give it key values rather than doing the value list. Find is select, and then if you pass arguments, it'll be the equivalent of your where clause or your sort clause. Drop is pretty obvious, but it's just telling it the object of customer, so the table customer, and then telling it to execute the drop function on it. The ensure index will create the index on the field and then the key value pairs. If that key is not there, it just considers it a null and ignores it. Remove is your delete, and update is update, where you just pass the values you want to change, and it will go through. And again, you can pass through a where statement as well. The update gets a little complex, but if you start working in NoSQL, it becomes fairly consistent, just like it took everyone a little while to get used to SQL in the first place. So I'm going to do a couple of quick demos here on this. So we've got our database. I'm going to be using our sensors database here. This is reading in data from the little temperature and humidity sensor and stores it into a couple of tables. The first thing is in the table list, we have a number here. Sensor data is the one I'm looking for. So you see just fairly simple data that we're storing through. We're going to come back to this in a minute. On the other hand, we can go in, we're going to use the Mongo client, localhost, so we're passing to the Mongo listener, and we're telling it /sensor, so we're going to the sensors database. And because I have a lot of data there, going to pull up the sensor. I have a JSON copy of the sensor data, and I can go in and pull that data. And so I'm pulling queries from these databases, going back and forth between Informix and Mongo. I can use any of the tables on either one. I can do the same functions on either one. It'll let me connect either way. So if I'm coming from a Mongo background with all my Mongo infrastructure, I can treat Informix exactly the same as Mongo. I just now have all of these extra features from a big, well-established, fast relational database. Whereas if I'm coming from an Informix background, I can go, okay, we want to start doing this with this Mongo app, or our developers want to start building NoSQL. Great, I just need to put this listener up, and I can just give them access to it, and they're good to go. I don't have to go through and spend days and weeks and everything else changing huge quantities or setting up a new infrastructure, getting it approved through security, et cetera, et cetera. We have all of the infrastructure already. So one other one here that I think most of the Informix folks will be very familiar with is the stores demo database. If we go in, we've all seen the customer table. If we do a customer find, and we're going to pass customer number 120, we get back, this is a standard SQL data table. I'm sure almost everyone on this call has seen the customer table in stores demo at some point or other. And we're returning the data, which is in a standard relational table as NoSQL, as JSON data through the Mongo listener natively. It works very cleanly. It's just as fast either way you want to do it. So the other thing I am going to bring up here is how Mongo applications work with it. One of the most fun ones, and Again, this is a live demo, so I will not guarantee there won't be a problem here, but is taking an application that was written for Mongo and installing it on Informix. When you do that, you should need to change absolutely nothing. So what I'm going to do is I've got an application called Calypso. If you're familiar with WordPress or Joomla or any of the other content management systems, this is a fairly well-known one that runs on Mongo. And everything in here is, I'll show you what the install file looks like. It just calls the Calypso, which I installed the binaries, just the installer earlier, creates the site, and then starts up the server. So it's going to run in the background. It takes a few minutes to go through because it sets up all the directories, copies all the files. So I'm kicking that off. This is, the old Julia Childs, put it in the oven, and then come back to it in a minute. So while that's going, I'm going to come up and start talking about the REST listener because this works the same as the Mongo listener, it just has some new features. So the REST listener. You start it and stop it the same way as the Mongo listener. The only difference is you change your listener type to REST. It'll handle REST commands, which some of you may be familiar with if you've ever done web-based applications, where it'll handle post and get commands the same as you do from a web server or JavaScript or anything else. It uses, just like the Mongo listener, it passes data both directions as JSON. If you start using the Bluemix data transfer service, number of the Bluemix services and transferring data up to it, it'll be using the REST API to do that transfer. Fairly efficient. There are no drivers needed. This will let you go out and insert, retrieve, update data from your Informix database with nothing installed. You can go do this from a blank system. Curl, you could do it with a straight web page, you can do it from your web browser, you don't need anything special installed. Technically, this came in 12.1 XC4. Mike and I spent a while on this. We found that the XC4 edition of this does not work terribly well. You really want to go with an XC5. So there are 4 methods with REST: get, post, delete, and put. So it translates to query, insert, delete, and update. A simple example would be a get /database/table, similar syntax to Mongo in that, and then passing through the parameters of sort on the age, and then we're telling it what fields we want. So we're telling it to bring back ID, and we're bringing back, we're not bringing back ID, we're not bringing back last name, but we're bringing back everything else. So we're giving the first name, Sherry, and the age of 31. So another way, and many of us have seen SysMaster, you can connect directly from a browser because all it is a TCP connection that just returns the data in raw form. So you can go in, you can connect to your Informix REST listener. You notice this one I have running on 26352, Mongo's on 26351. These are entirely arbitrary ports. They can be on anything else. I stole this example from Mike when he did it on his system. His was on 27081 or 018. Be on whatever you'd like it to be, as long as your firewall lets it through. But what it lets you, in this case, we're going to do a query against SysMaster, systables, and doing it, we're casting back the tab name, and you see that's exactly what we get back. And to do the nothing up my sleeve, I actually have it up here already. And this is connecting to my REST listener. I am going to refresh the page. Oops. As I said, live demo. But in this case, I've got another one up here where I actually am requesting my sensor data. So this is raw sensor data. This is anytime I'm looking for where the value, in this case, the temperature is less than 20 Celsius, and it shows me every entry where it is. If I view it in the view page source, oh, it doesn't word wrap. Shoot. And I'm seeing when it broke on this. There we go. I think I had an extra space there. So I run it, and I get back my list of tabs. Notice it is in JSON format. So I could go from any application, take this, pull it back, and get my results back. You know, I've used the curl command line application. I've used all sorts of utilities out there to do direct REST commands. There's a number of free applications just to directly modify it. I pulled together a very simple application. Notice this is storesdemo.html. This is a flat HTML file. There is nothing that's going against the server. If I do view page source on this, I include jQuery, and I've got a small JavaScript file here. But notice there's nothing, customer name, company name, address, everything is blank right now. There's no data loaded. Yet when I go to choose one, I've got all of my stores demo data, and when I select one, it's pulling up the data. How is it doing that? My browser itself, my local browser here, I pulled the web page from the web server, pulls up, but it then goes out and requests from the REST listener this data and updates the page dynamically. That data request never goes through the web server. It goes straight from my browser to the REST listener directly and updates the page dynamically. I will include this source code if anyone wants to play with this. It's very, very simplistic. Just a little bit of jQuery, one that updates that select box, and one that then populates the fields underneath, whichever one is selected. Very simple, but is very easy and quick to get started using this. So I'm going to jump back now and see if my Calypso is now running. So let's see if this will work for us. So we've got now a Calypso installer. It is up and running. Note nothing has been configured at this point. It passes, one thing I like is with Calypso, it actually passes a password to you during the install. So you have to pass it through so you know that it's the same person doing the install. So what are we going to do? We're going to tell it to connect to Mongo database. And in our case, we're going to pass it on, use localhost. And then I'm going to just pick a database name here, test WebEx. And it worked. Because what it has just done is gone through using all of the standard Mongo utilities. This application is in no way written to support Informix. Going to create my admin. I can do all kinds of sample stuff I want to. Save and install. And what it's going to go through is generate the site, and now I have a full application. I can go in and modify, handle, and everything should work the way I'm expecting it to, the same as it would if I was against a straight Mongo application. And the same token, if I go back to my Informix system, there's now a test WebEx database here. It automatically created it. It automatically created all the tables, and everything is done. And it thinks, and the application thinks it's against a straight Mongo database. Again, they have done a very nice job of making this interoperable. So getting back into REST, there is a lot of functionality here, a lot of opportunity for increased Informix increased Informix presence in your organization, because you can take your existing data, your existing schemas, everything else, and then include other applications into reading it that may not have been supported Informix in the past, or this may just make easier and new ways to do it. There's lots of security concerns involved with all of this. I'm not going to go down that path. That is, of course, a individual requirement for each organization. So next thing we're going to talk about, change gears a little bit here, is Node-RED. This is a free open source tool based on Node.js that IBM has been supporting for a little bit. It is a visual tool, little to no programming needed. They say no programming, there's some that's actually needed here and there, but it's pretty lightweight. Everything is drag and drop. It can handle many types of data and through a whole lot of freely available modules. Interfaces extensively with IBM services. They've done a lot to make their nodes work cleanly with things like IBM Streams, Watson, Bluemix, a lot of their other services. Google as well as a number of other parties out there have done custom modules to support Node-RED. So it runs in a browser. It's running as a Node.js application on a server. What you do is you create data flows and apply operations, apply functions to them. So you take your data, you stream it through, and you make changes or stream the data to wherever you need to. So it can come in from point A, go out to point B, C, and D. A little bit of what it looks like here. The install. If you have NPM installed, which most systems will, or it'll be a one-click to do, npm install -g node-red, you run node-red, you're done. It's really easy. To install a module, you go to your node-red directory, npm install, and then node-red-node, and then the file name. So each one will tell you. If you go to there's a number of resources out there for Node-RED modules. They'll give you a very detailed walkthrough to how to install it. It's very simple though. If you're looking at running this, I highly recommend a utility called PM2. It lets you control the services, automatically manage it, start and stop, etc. It works very nicely. One other thing, technology I'm going to mention here, this does not directly translate to Informix, but it is very common in this world, is MQTT. It's MQ telemetry transport. It's taking data from point A and to a broker, and then you have subscribers that will come up and read that data out. So you get you subscribe to, or you connect to it, you publish data, and then you have subscribers that read from it. So this is another way to take data from point A to point B, and it's similar to NoSQL in a fairly open way to put in the data. It's fairly unstructured. There's a lot of available servers out there. WebSphere has an MQTT add-on for it. There's a number of other IBM products that'll support it. In this case, I'm actually using one called Mosquito, which is just a free, lightweight open source one. So I'm not going to get into a lot of details with MQTT other than I'm running it here, and I'll be showing it to you in a moment. So going into Node-RED. This is one bit of technology, to be completely honest. When I first saw it, I'm trying to find my tab here. When I first saw it, I thought this was going to be something that would be a toy, something that was half-baked, something something that wasn't really going to be useful, and I have been proven very, very wrong. I actually run this regularly at home. We're running this in the office. Number of major places are actively using this because it makes it very easy to take data from point A to point B. If you're doing huge data loads, I would still say use your standard ETL tools. I have not stress tested this, but I would imagine that your standard ETL tools will be faster. But if you're dealing with streams of data and standard speed, data coming in from different sources, this works really, really well for being able to manage that data. In this case here, we have a number of sheets. The most simple one here is I've got a Twitter feed. This is a very simple Twitter node connected to my Twitter account. And what it does is it looks for anything with the Informix hashtag or the @Informix. And all it's doing is sending it to a very simple debug. So this will actually show up in the debug window. I was hoping we'd get a couple of Informix tweets during the class. Apparently hasn't happened yet. But if they come in, they'll pop up in the debug window. I could also take those and do whatever I want to with them. The first primary sheet, though, is where I've got my data coming through. I've got two sensors here. One is my temperature, one is my humidity. Both of these are listening to my MQTT. So what I have happening is I have that little sensor piece, my little sensor device that's connected to my Wi-Fi that every 10 seconds does a temperature and humidity reading and then sends it over to the MQTT broker. That then Node-RED is subscribed to that broker, so it sees that data coming through and will pick it off. So what I can do is take a debug window, drag and drop, connect it into my temperature. I can deploy it. And now every time something comes through, I'm seeing the raw data over here in the debug window. The same token, it's also going up to this thread up here, which what I'm doing on this one, and that little green button turns on and off the debug, by the way, is I go through to a function node, and I'm actually adding in some JSON headers, so it actually turns the whole temperature value into JSON for how I want it set up. And then I take that data, and I've got a little PHP script that takes this and inserts it into my Informix database. So it's going in, and every time there's a temperature reading, it goes in, takes that data, sets it up as an HTTP packet, and then sends it over to my little web script that'll go and insert it. This could be any kind of application, but just doing a straight TCP call, and then I've just got a little debug window here. Again, I can just delete them. The same token, I could do an MQTT. I've got MQTT in here. I'm going to do MQTT out. So it comes in on one thread, one name here, which is on the sensor's temperature is the topic, and that's what each MQTT piece has a topic you subscribe to, so you can have multiple running in parallel. I'm going to create a new one here. I've already got my broker set up, the server set up. I'm going to call the topic data. And there's lots of things I can configure. And what I've got up here, I think that's the right one, is a small command line utility for Mosquito to subscribe. And I'm going to subscribe to the topic of data, give it my password, username, password. And nothing's coming through right now because there's nothing actually publishing to it. But I'm going to deploy this, so it's going to push the changes out. And now when I do this, the next time a reading comes through, I'm seeing this because I'm now subscribed and I'm reading the MQTT data. So for everything that comes through, I will go ahead and get that data. And the same token, if I want to see the humidity data as well, I get that. And now what I'll see is coming through, I see the humidity data and the temperature data. So it all comes through. You'll notice the temperature readings are a little variable. I think I have a really, really cheap temperature sensor, so it's partially in light and partially in shade depending on where it is next to the window. So it does vary a little bit. So that's what's going on for my data stream. So that is my little behind the scenes data stream. So what else can I do with this? I can go in and just for some of the nodes here, you see the input of, you can do a manual one, you can do MQTT, you can do it from a web request. So you can actually say, if there's a simple web service that's listening, you could have something basically published to Node-RED directly. You can have a socketless and TCP serial connection. So if you're connected, you have Node-RED running on a device with serial connections, you can have that feed data. IBM IoT, so if you've got the IoT node for Bluemix, that'll can send data. Then you have your output nodes. This is where it goes to. We saw debug and MQTT. We can send HTTP requests, WebSocket, TCP. So you could send this if you've got other applications out there with TCP listeners or other things. It can send to it. We can also send out to IBM IoT. So we could take data from our sensors, send them through, convert them, and then send them up to Bluemix on the IoT system. There's a lot of things we can change. We can delay, we can switch, we can adjust, we can change things to different formats, CSV, JSON, XML, etc. We can receive or send email. So we can have this trigger an email. We can look for Twitter or post to Twitter. Anytime that, my temperature is above 100, it sends out a tweet. Sure. If I want to connect to IRC and, have it act as a bot anytime something happens, sure. If I want to have it translate through Google, if I want to have it look up if, any of the readings are in, something triggered on Google, absolutely. I can have it post to Google Calendar. I can have a tail from a file. I can use time series data directly from Informix. I can go Mongo, which I'm going to do right now. So I'm going to take my data, my temperature data, put on a new Mongo output. Got a service already configured here for my sensor database. I'm going to create a new collection. So this is going to be a new table. We'll call it WebEx temp data. We're going to save it. I'm going to call this Mongo storage. I'm going to deploy this. And it's going to go through. We're going to have some data read here. And going to bring up DB access again, connect to our sensors database. Now we have our NoSQL WebEx temperature data table created for us. And you see how the data is automatically created. It has a unique ID, mod count and flags are there if it needs them, and your data. That's all it's storing by default. But we can go in and change this to and now we're actually getting the raw data that we're getting from our sensors stored in NoSQL in Informix, read for through DB access after being stored through the Mongo listener off a Mongo node. It is very, very nice how they have made all of these pieces work so nicely together. Also, just mentioning a few other ones that are kind of fun, and there's a whole slew of other nodes available. You know, you can do feed parses if you're looking for those. If you have Alchemy, there's things with that. There's a whole section for IBM Watson. So if you're subscribed to the IBM Watson service, you can actually stream your data through that using Node-RED. You don't need anything else to do it with. You know, again, Google, you know, you can Google Calendar, you can connect to weather. So if you're looking for a particular weather alert, you could have that trigger something through this. There's a lot of different options and a lot of different things you can play with. So here's the best part about the whole Node-RED piece. It's free. Free for commercial. You can go download it today, start using it, and you're good to go. It is making your lives easier. It, of course, works with Informix. It does work with other databases as well. But IBM's doing a lot to make it work with especially the Bluemix, the IoT, and the time series pieces of Informix. So I am a huge supporter of it. So going into the next one, which is Spark. For those of you not familiar with Spark, this is a project from the Apache Foundation. It is what's intended is a real-time, entirely in memory data storage system and data analyst system. It's meant to have a whole bunch of different types of data brought into a single place and then sliced and diced entirely in memory and then spread across multiple systems. This is back to the NoSQL concept of horizontal scaling. It's the big thing that they push with it is the fact that you can do real-time analytics because you're streaming your data into this rather than with such things as the Informix IWA system, the warehouse accelerator where you do bulk loads. This will let you fully stream your data and do the analysis entirely on these streams of data that are coming through and being stored in temporary and permanent ways. It's more of a framework than it is a final system, but IBM is putting a lot of time and energy into it to make it work with a large number of the IBM portfolios. So it's open source, so it is freely available. IBM's working with it. The biggest thing with it, though, is Informix is no exception. They are, in particular, putting in a streams index type to Informix to allow it to stream data natively to Spark. I'm not saying anything that's NDA here. This was actually demonstrated at the IBM Insight. However, this is still in early beta stages and is not publicly available yet. I'm saying information coming soon because as they're working on it, it'll eventually hit the release system. Hopefully there'll be some level of beta that can be tested with it, but I've seen it in action. If you're at Insight, you may have as well. It is very cool because it lets you take Informix, set up a output streaming system to send data directly from Informix to Spark or to other systems for that matter. And so that is something very cool that is up and coming. And Spark in general is a very neat technology that, as IBM continues to take their portfolio and make it work nicely with it, there'll just be more and more opportunities to take your organizational data from wherever it's coming from, as we're all collecting more data these days, and putting it into this one place to then let your analysts go through and figure out, what is the weather data coming up? What does that mean to us? What is the last 2 years worth of weather in this region? What does that do to our trucking schedules? What is the average temperature of our fryers, means to the opinions of people from, on Twitter. Whatever it may be, there's lots of different data we are all collecting now for our organizations, and we're going to be doing even more in the future. And this is a really interesting direction for IBM to be pointing in, to really be trying to centralize some of that data and allowing us to do analysis on multiple types. So the other upcoming one I want to highlight here is IoT data visualization. This is a beta project, but it is open beta. You can go download this today. Right now, it is only available on Docker. It's set up to work with traditional end time series data, but this is specifically for Informix. This is an Informix particular one. If you get the Docker image, it actually includes a copy of Informix with it. What it is it's a tool to graph out your Informix data. And to give a couple, and I stole these images from their examples, because again, it's still in beta. The current version was not working for me, so I used their pre-canned images. But it is as simple as you choose your data source, which can be a time frame, a node, connection source. You go in, you give it your attributes, your what you want to group by, filter by, what you're actually looking for in there. Do you just want the outliers? Do you want everything? Do you want aggregated, et cetera? What scale do you want it on? There's all kinds of things you can set up. And again, you get line charts, bar charts, area charts, and there's lots of subsets for each one. And that's all you have to do. And then you have these charts with rolling windows at the bottom that you can do all sorts of other stuff with. Again, this is in beta. If you can get it to work, it's available now. They are actively working on it. If you go to any of the places that IBM is doing demonstrations of new technology, they'll probably have a demo of this. So I'm hoping we should have one at the IBM conference coming up in May. So again, you can give it date ranges and all sorts of things where it's meant to take your traditional, analytics and overlays and everything else, and then allow you just to directly put it against your Informix data sets. They do specifically have ties in for time series in particular, so if anyone's running large time series installations, this may become very useful. So going into it, just some general links here. Again, we'll be putting these slides out so don't feel you have to be jotting notes down really quickly. There's a huge amount out there about NoSQL, JSON. The Docker link here for the IBM for IoT visualization is the direct link if you want to. There's a really good IBM article in setting up the wire listeners. There's the document from IBM comparing the commands. I use that as my reference point for doing the chart of mappings, information on your REST API, getting up and running with Node-RED. It really is that easy, but of course, looking at the documentation is not bad. Flows.node-red.org is a good site for getting extra nodes or modules for it. IBM Spark site, I wanted to break this out, and another link to the Docker for data visualization, because I think that is a really cool tool, and information on what IBM is doing with Spark. We've got our webcast. We've got quite a few out there on Informix, on ARM, the Internet of Things. Go have a look. If you missed part of this or you want to send this to somebody else that wasn't on the meeting, we'll have this replay out, and usually it's 2 or 3 days. A couple other useful links. If you have not seen it, Carlton Doe keeps a running list of the different Informix versions. I just like to put it in all of mine. IBM, if anyone coming from the Mongo world, you want to get up and running quickly with Informix just to kind of try it out, play with it. IBM has a Docker site for Informix Innovator C, which is the free edition. So you can go install the Docker image. It'll put everything else out there for you. Also, they do have a set of Informix VMware images that are also freely available. And then we also offer training, so it is all up there on our website, advanceddatatools.com/training, and then we have a whole set of Informix training. We're right now working on finalizing dates for 2016, so we should have those announced fairly quickly. So we're going to do questions here. If you have questions, please send a message to me or to Lester in the chat. And well, that's doing a little bit about us as a corporation. If you've not seen this before, or if you've not seen one of our webcasts, we do training, we do Informix consulting, development. We offer remote DBA support and monitoring. This is not just replacing DBAs. We also work hand in hand with DBAs in many cases where we offer just that little bit of backup, that little bit of extra monitoring to help out the DBAs, because we know you all have 15 other things to do at any given moment. We do an extensive amount of Informix performance tuning, come in, make your databases scream. We also have our free webcasts available. If you have any questions, anything you'd like to know, feel free to email us or check out the website or give us a call. One other thing I'd like to announce is, for anyone that doesn't know, we'll be having the IIUG, the International Informix User Group conference. This will be in May 4th through the 8th in Florida. It's going to be awesome. It's iiug2016.org. We have it on the website. And it is in Ponte Verde Beach, Florida, and I think I just butchered that name. It's near a little bit off of Jacksonville, but it should be a wonderful location. It's great, highly technical conference. Go through, meet the developers, meet a lot of experts, meet a lot of users with a huge amount of experience, as well as plenty of people coming in brand new. It is a very, very useful conference for anyone involved with Informix or looking to get involved. So Lester, anything you have to add, any announcements? I haven't gotten any questions yet.
Sorry, Tom, I had to unmute myself. No, I think you've covered it all. You might want to bring up the IIUG conference website so people can see what that looks like. But thank you all. And as Tom said, we will have a replay of this webcast up in about, let's say by Friday. It may be before then. And we'll have our training schedule, and we're working on a webcast schedule for next year. If anybody has any suggestions on webcast you would like to hear, please let us know. Right now, our initial thinking is to do a series on webcast for new Informix DBAs. I've spent this last year training more new DBAs than I ever have. It's been an absolute blast, a lot of fun. A lot of Oracle DBAs are suddenly having to learn Informix, which is always interesting. And so we might do a series on that. Another topic that we're thinking about doing for next year is running Informix in a VM environment, a virtual environment, since a lot of people seem to be doing that, and they run into performance problems with that. And we'll talk about that sometime in the future too. And Tom's got the website up for the IIUG conference. Is
registration is open.
Yes.
Yes, it is early bird registration right now. Highly recommended. If my other hat is I am on the IIUG board of directors. If anyone has any questions about the conference, feel free to drop me a note. Tom at advanceddatatools.com works fine for either any questions on this webcast or any questions on the IIUG or the event. So thank you all very much for being on. Again, the replay will be up in a couple of days, as will be the slides, and I'll put up my sample scripts for the REST listener HTML and jQuery.